just like we did for arithmetic progression, I want us to discuss the logic behind the formula for the nth term of a geometric progression. Let's come along. The first term, or the number that starts any arithmetic progression or geometric progression, is always what we call first term, and this one is A. First term is always A. First term. Okay. Now, let us look at the relationship or what connects the neighboring terms together. If you look at it very well, you will see that each of these terms of this preceding term has been multiplied by 2. That is, relationship between this and this is 2. Relationship between this and this is 2. Relationship between this and this is 2. So these 2 is what we call common ratio. That is, if you use 2 to multiply the first term, you will get the second term. If you use 2 to multiply the second term, you will get the third term. 2 multiplied by 3, 6. 2 multiplied by 6, 12. 2 multiplied by 12, 24. And so on like that. So these 2 is what we call the common ratio, and it is always known as R, represented with R. Now, let's come down a bit. This one, we call it, like we said is 3. Then this one, what we are trying to do here is to arrive at the formula nth term of a geometric progression. Now, to do that, we have to, for each of these terms, we are going to give an expression to each of these terms. And then, to do that, we are going to keep the first term constant. Okay? So, this one remains 3. Then, this one is going to remain, we are going to call it 3 multiplied by 2. Okay? Then, this one is 3 multiplied by 4. This one is 3 multiplied by 8. Okay? Now, if you look at this one represents, that is, no common ratio is used to multiply this, so it remains 1. This one is 3 into 1, 3 into 2, 3 into 4, 3 into 8. Now, look at this. We want to give an index to each of the ratios. Each of the ratios. This one means 3 into 2 raised to power 0. We are still writing 1. 2 raised to power 0. The reason why we are choosing 2 is because 2 are the common features in our expressions here. So this one means, this one also is 3 into 2 raised to power 1. This is 3 into 2 raised to power 2. This one is 2 into 3 into 2 raised to power 3. Okay? Now, what is the implication of this? What this one actually means is that when this 2 raised to power 0 is a function of, or is a matter of deducting 1 from each of these. Okay? Now, this one is 1. So, the implication of this is that this is 3 raised to power 2 into 1 minus 1. Okay? That is 1 minus 1. If you deduct 1 from 1, you are going to get the index of your 2 here. This is 0. This one also, this is 3 into 2 raised to power 2 minus 1. Okay? This one is 3 into 2 raised to power 3 minus 1. And then this one is 3 into 2 raised to power 4 minus 1. Okay? Look at it very well. This is 2 raised to power 1. So, how we have gotten 2 raised to power 1 is by deducting 1 from whatever term you have. So, this one is 1 minus 1, that is 2 raised to power 0. This is 2 minus 1, that is 2 raised to power 1. 3 minus 1, that is 2 raised to power 2. 4 minus 1, 2 raised to power 3. So, the implication of this now is that, therefore, when you have this, what are you going to have for this? If this one can give us 2 minus 1, then it means we subtract 1 from this to get our term. Then this is 2. 2 minus 1. 3 minus 1 to get the third term. To get the fourth term is going to be 4 minus 1. To get the nth term, now follow that this one is going to be 3 into 2 raised to power n minus 1. Now, what are we having here? This one is 3 represents A, 2 represents common ratio. Therefore, you can say generally nth term of a GP is equal to, this is A, so this is A, then 2 is our common ratio, R, then n minus 1. So this is how they have arrived at the formula. I hope you have enjoyed the explanation very well. If that is the case, why not follow our page, share and drop your comment in the comment section so as you'll have your feedback. Thank you for watching. Bye.